climate change is not really the problem we're concerned about. Climate change exacerbates other problems. Heat waves are not a problem until they cause health impacts, right? And what we need to do is we understand is we grapple with these problems and we come up with the things that motivate us to do something about it. Maybe what ends up motivating you is when a relative dies because of a heat wave, right? And this happened, right? Our last European heat wave, some 20,000 people in Europe died because of that. And heat waves will become a lot more severe. So again, there's all sorts of different angles and different perspectives that allow you to enter into position. And I'm sorry for assuming that your reason for being here is somehow intrinsically derived from the faculty you're from. It's just interesting for us to see where you guys have all come from. Right, okay. So if we're going to talk about emotions, then we have to sort of start with our personal experience. This is the farm that I grew up on in Ohio. Oh, should I dim the lights a little bit? Is it just the normal university? It's very cluttered in math here, which is not at all surprising. That's probably okay. We don't. All right, so there's the farm. It looks very clean. There's no animals or anything. That's because it was a picture that we were taking as we were about to sell the farm. Our farm was very small. It was a dairy farm. We had about 25 cattle on it. That is a really, really small dairy farm. And I didn't really realize this till later, but I think I internalized the lesson. But basically, when you're small, you're vulnerable. When you're poor, you're vulnerable. I don't make too much of this. I don't tell this story. No one wants to hear about, like, I was really poor, I grew up on a poor farm. No one wants to hear that. But, emotions come from your experience and what you've done. And I grew up on a really, really poor farm. Even the normal farms in my area, in this area, they might have twice as many cattle and such. And I saw not the lesson of climate change, but I saw the lesson of weather. Everything was uncertain. Everything was wild. My parents would cut the hay, and if it rained the next day, that rain, it was going to rot in the field. If we rushed to put that wet hay in our barn, there was a really good chance that the barn would catch on fire. There were times where we had to take thousands of hay bales out of our barn to dig around because we knew there was a hot, wet bale with anaerobic activity in it, and if we didn't deal with that, our barn would burn down, and it happened to our neighbors. We understood that the variable, unpredictable nature of weather cost us money. And whenever you have a year that was too wet, our neighbors' farms would go out of business. And you have a year that was too dry, other farms went out of business. We didn't go out of business because my dad got a part-time job driving a bus. Then my mom got a job being a secretary. And eventually, nothing to do with weather, my brother and I went to uni, and the farm just couldn't survive. And you learn from that unpredictable weather, which will only be made worse because of climate, or environmental change, or a decline of urban pollinators, or a decline of biodiversity, these things will not affect all of you equally, and it will not affect all of the world equally. Some people are more vulnerable, and other people are less. And I didn't really realize how much that lesson personally affected me, even though I became a climate scientist in, like, say, 1992 when I started my PhD in this field. I didn't realize it until Hurricane Katrina. We spent a lot of time debating, was this caused by climate change? Or did climate change make it worse? There's a terrible example to study that because hurricanes are really quite tricky. Wrong lesson, wrong conversation. What we learned from Hurricane Katrina is who suffers when climate change happens. When extreme weather happens, who is it that suffers? It is not fair. And we see this again with the Cumbrian floods. If you got a lot of money, you can get out. If you don't, you're going to be more vulnerable. You're more exposed to the risk, and you'll bounce back more difficultly. So I don't often talk about my emotions in this context. What I often talk about is ethics. I'll be honest, I don't talk about ethics very often because, you know what? Saying that we're all bad people for our lifestyles is not necessarily a good way to motivate change. But you're all here because you want to make a difference, so we can be honest with one another. And we can be honest with one another and say, this is an ethical issue. I don't know what your emotional response is, but I'll tell you my emotional response is that it pisses me off. I get really, really angry. And that's not necessarily the best way to come up with new solutions, but it's what gets me out of bed. It's what motivates me. I don't get depressed. Depression doesn't do me any good. It doesn't help me get angry, because I remember seeing my neighbors, my friends, farms go out of business just because there was a wet summer. So these are the types of issues you have to find within yourself. What makes you optimistic, hopeful, angry? What motivates you? So what I want to do is in the time I have, I want to talk a little bit about the climate change challenge, what it represents, and then finish, because you're going to think about some solutions, is think about where we need to go. Some provocations about what it will take to become sustainable, and some provocations about the climate change that does happen, and how we're going to have to adapt to that in a much more fair way than we have been. And it's all sort of a bit random. You're all here because you know about it. It's just throwing out a lot of random things for you to ponder and think about. So we'll start with what we know about climate change. I always start with this saying, how do we know anything about climate change? And how do we know? Well, because we measure things, but we've not been measuring things forever. We've got these records going back a century. We're early into the experiment, but we measure things. And that's how we know that this year the surface temperature of the Earth was the hottest that it's been in recorded history. So that's part of understanding things. We make climate models. That's less about measuring and seeing what happened, and more about how the system works. And there's one other component. This is what I do, is I study dinosaurs. I don't really study dinosaurs. I study the past. I study what the world was like in the past, to get a sense for what the world might be like in the future. I'm not going to talk about that, but there's two things about past research that informs how I think about this climate change challenge and why I really worry about it. First, we're at 400 parts per million as an average. Technically, today, we're at 404 parts per million. That, to the best of our understanding, is the highest the world has been for 3 million years. 3 million years! We have no fucking idea what world we're creating, right? It is unprecedented in human history by a far amount. Moreover, I'm allowed to swear a little bit because it's all about emotional engagement, right? But normally I would be more restrained. The other bit is that I've spent a lot of my time looking for very, very fast climate change events in order to understand this fast climate change event we're doing now. And actually, it's beginning to become somewhat of a research dead end, because our fast climate change events of the past take place over 1,000 to 10,000 years, 10 to 100 times more slow than today. So we are really, really at the thin edge of our knowledge and our experience. And this is another reason why we're emotionally disengaged. Because no matter how much I can present scientific evidence, what we think about the world around us comes from our experience. But when it comes to climate, and for that matter, the environment, biodiversity loss, plastic in the ocean, our experience is largely useless, because we've not experienced anything like the world that we're creating. Even today, at 400 parts per million CO2, we will not be living in that world for about another 15 years because of the delay in the climate system. So I'm not going to talk anymore about my own research in the past and dinosaurs and things like that, but this is the reason we have a big plesiosaur on Park Row, swimming around, making people think about it. It's because we're creating a very uncertain world, a very uncertain planet, and that seems insanely risky to almost any geologist you will talk to. Okay, right, so what are some of the lessons that, and these are lessons that, this would have been different if I had written this talk a year ago. These are largely lessons that have been refracted through the lens of the Green Capital. Talking to a lot of people about this, whenever I give a talk about climate change, I talk about all the issues, and my final point is, but climate change is not the only issue. Everybody says, you've got to lead with that. You've got to lead with that. You don't put it as an afterthought. Make it a main thought. And they're right. Climate change is not the only environmental issue we face. We have a growing population, a more urban population, a growing global middle class, and as a consequence, we're consuming more. And there's places you can go on the internet and you will find 100 of these figures. How much we use water, the number of dams, number of cars, paper consumption, fishery stocks, and all of it exponential impact because of our increasing consumption. That's one of the big impacts on our planet. We need energy. We depend upon energy. We are in the midst of an energy transformation. How fast we go, what we go to, big, big questions and challenges for the environment. We need food. This is from the Depression, feeding cattle cactuses, you know. So I like this because it sort of shows that we're clever, even in the most extreme settings, but clearly we need food. And related to food, we need water. And as we all know, water is a really, really tricky one because you need enough of it, but you can't have too much of it. So water is, again, a real challenge for us. And all of this, food, water, energy for a growing population, a more consuming population, all in the context of a globally changing environment. That, again, not just climate change, more pollution, biodiversity loss, all sorts of environmental issues that we grapple with. And this is what we try to study in the Cabot Institute. We have themes around all of those, and we try to bring them together because they are all interconnected. But this is a very, very limited slide because we also know that we have problems like an aging population, underfunded NHS. We have population of people where a significant number of our own citizens are malnourished. We have gross inequality, especially in Bristol. In some wards in Bristol, you have neighboring wards that have a difference in life expectancy of 10 years. I forget what wards they are. I think it's Southmead and Henleys. But if you're in Henleys, there's a Warfield. Henleys. Right. If you're in Henleys, you can expect to live 10 years longer than your neighbors in Southmead. That's inequality. That's health. And all of those issues are exacerbated and compounded in this matrix. So we have to think about all of them collectively. And the types of things that you might think about your solutions may not be, maybe one of the things that we do to deal with climate change is we eliminate inequality so that we're all at least equally prepared, or we're in a good state that we can grapple with climate change equally. I think there's a myriad range of solutions, and we will need every single one of them. So when you go to discuss, I think one rule, you guys will probably say this, there will be no bad ideas because we basically need every single idea we can get. Right, so I talked about this limit of what we know. I'm going to explain a little bit of that in a moment. I always think that it's vital, and Steve Lewandowski, who'll come and be involved with you guys later, will emphasize this. Just because there's some things that I can't tell you doesn't mean there's not some things that we don't know. We know, we've measured it. We burn fossil fuels, it makes CO2. CO2 is increasing it. Good old-fashioned, solid analytical chemistry. We measure it, we know it's happening, and we know that it will lead to warming. The red curve, that's if we carry on as we are. That's how much we will warm our planet by about a little bit more than 4 degrees. Let's just say 4.5 degrees. That's how much we'll warm the planet by the end of the century. Now, there is uncertainty in how much. Maybe it's 3 degrees. Maybe it's 5.5 degrees. And that's a probability range. But it doesn't change the fundamental fact that if you turn the gas on your hob, the pot will get warmer. It's physics. If you add CO2 to the atmosphere, the Earth will get warmer. But there's a little bit of uncertainty to that, and that uncertainty affects how we're going to have to adapt. I always put this slide up just as a brief caveat to the previous one, which is when we think about a world that might be 4 to 4.5 degrees warmer, that's not 4 to 4.5 degrees everywhere. For all sorts of reasons, some parts of the world will warm less, and others a lot more. So again, different people will have to bear different consequences. Okay, so I've alluded to this kind of real big uncertainty, that this has never happened before. We're at the thin edge of our experience. We don't know what will happen in detail. And that's not true. But this is a good slide that gives you a sense of the limits of our understanding. Most of us don't care about the globally average temperature. We care about things like heat waves, we care about floods, we care about drought. This is how rainfall will change in the future. So blue colors, that's more rain. Red colors, that's less rain. And what you see there in the broad colors is fairly well understood climate physics, which is the dry areas of the world get drier. You see sort of like if you look in Africa or Mexico or the Middle East, dry areas get drier and the wet areas will get wetter. Yay for us, because as if that's what we need. But that's fairly well understood. What is less understood? Take a look at the stippled areas, these sort of areas with the dots. Those areas, that's where the climate models agree on the sign of change. 2/3 of the ensemble, 2/3 of them agree on the sign of change. So for example, you can take a look at sub-Saharan Africa, or the central part of the United States, where a lot of the world's food is made. There's no stipples there. In other words, although models generally suggest those areas will get drier, lots of models suggest they'll get wetter. Now we have to adapt to this world. We have to come up with flood defenses. We have to come up with irrigation plans. We have to find enough water to feed the people. We have to find enough water to grow our crops. And in Texas, we have to find enough water to frack as well. We have to find enough water to do all those things. And I can't tell you whether it becomes wetter or drier. With respect to Bristol, I can't really tell you with much confidence whether or not Bristol's going to get wetter because it's more drizzly, or it might actually become drier in general, but more intense, more episodic rainfall events. These pose completely different problems in terms of flooding and water management strategies. So this is what I mean about there being some deep uncertainty. And this is a world that your solutions are going to help us navigate through. Another point that was made quite clearly this year is how complex our society is. A small change can have huge impacts. So it's not just the uncertainty associated with what happens if will it rain more or will it rain less, but there's huge uncertainty that if it rained more, what really would be the consequences? We all know how vulnerable Bristol is. You knock out one road during rush hour and the whole city shuts down. So society is complex and it's globally complex. That pie chart shows us where our UK food comes from. And it's not too bad. About half of it's made by the UK, the half of it is made by the rest of the world. So if I want to understand what will affect food poverty in the UK, I can't just look at a map of the UK. I need to understand where our food is being made all over the planet. It is possible that a drought in California causes a global increase in food prices and exacerbates food poverty in Lawrence Hill, here in Bristol. So we live in a complex, interconnected world. And then finally, I'm going to come back to the last point, which is really important, and I'm going to spend some time on this because this is, again, comes back to my emotional engagement. Is this profound inequity in the challenge? And as I said, I don't have a chance to go off about this very much because I'm not going to go talk to a bunch of people and say, do something about climate change. If you're not, you're a bad person. But between you and I don't think that, right? I want to encourage everybody to engage with this in some way, whatever way they possibly can, in a small way, in a big way. If someone wants to stop, if someone wants to drive less, great. If they want to stop driving entirely, great. If they want to sell their car and not even have a car, great. Whatever they have to offer, I want to encourage that. But again, what motivates me? This inequality that we saw in Hurricane Katrina. So, this is the global inequality. This is a figure, I forget exactly where this figure is from, but it's derived from IPCC reports. This is a map of the world on the top, with countries blown up or shrunk down based upon their contribution to climate change. So you see the usual suspects. China's a bit big, United States, we're nice and big. UK, we can't be too smug here either. We're quite big relative to our actual geographical size. Figure on the map, and this is really hard to predict. There's a big uncertainty with this, but it gives you a sense of the issue. Bottom map, climate change deaths per capita. So you're clearly seeing that those who cause climate change, generally wealthy nations, are not those that will suffer the most. Profound global inequality. I'm not going to talk too much about this, but let's recognize the other big bit of inequality in the room, which is One generation gets to thrive off of burning fossil fuels, and we're passing on the bill to you guys. There's an inequality that should, if you're not pissed off about this, you should be pissed off about the mess we've left you. And your kids, your kids are going to be really displeased at their grandparents and their parents. So there's an intergenerational inequality. We can look a little bit more about how this manifests itself. Again, floods are a good example. Hurricane Katrina is a good example. Why did it affect them the most? All sorts of reasons. One is they're poor. We just take it as read that in America everybody has a car, and everybody has cousins or uncles living in other parts of the country. So a lot of people, they were able to just get in their car when the warnings came, and they drove to Oklahoma or Missouri. They got out of the way for a couple of weeks, came back, they dealt with their flooded home. Not everybody has a car. Not everybody can afford to put petrol in the car. Not everybody has relatives living in the other country who can take them in on a spur of the moment. There are all sorts of reasons. But also, we found out in the decade afterwards that certain areas, the poor parts of the city, the infrastructure had not been maintained as well. They were more vulnerable to being flooded in the first place, and when the floods came, they had less resource to respond. This will happen in this country by statutory obligation. We build flood walls, we build flood defenses in this country based upon the economics. In other words, if there's 8 pounds worth of damage, then I'm allowed to spend 1 pound on flood defenses. That is what the EA is charged with. 1 pound to save 8 pounds. So, if you live somewhere where your house is worth 800,000 pounds, or if you live somewhere where your house is worth 80,000 pounds, where is the EA statutorily obliged to put the flood defenses? In other words, we are deliberately embedding a structure that means that the poorest in this country will become more and more and more susceptible to flood risk because they live in the cheapest houses. That's quite perverse. Well, I always ask people if they're concerned about global warming itself. I kind of joke, warming isn't really the problem, especially here in Britain. It's true, but heat waves are. This is a map of the 1 in 20 year heat wave. So I don't know exactly what the 1 in 20 year heat wave here is in Britain, but in my experience of living here, I've lived here for about 15 years. Probably the extreme heat wave you get every 20 years is somewhere around, say, 33, 34, 35 degrees. That's a pretty hot heat wave. If you look at the figure, the really dark colors, which sit right over Europe and Britain, our 1 in 20 year heat wave, currently around 35 degrees. At the end of this century, if we carry on what we're doing, will be about 45 degrees. That is a nasty heat wave. Now we learned the consequence of the heat waves this summer when they hit India. And so who died in the heat waves in India? Manual laborers, the people who didn't have the right to go home. The ones who couldn't say no to their job, the ones who couldn't turn on the air conditioning. They were manual laborers, they were more exposed to it, they had less power, they had less freedom, they were locked in because they couldn't say no to their jobs. All of these things, for all sorts of reasons, will affect the poorest the most. I'm going to skip over these slides because I feel like I'm getting a little bit overly preachy, but I hope I'm getting appropriately emotional, and that's coming across, is that this should make us angry. And food is the same. And I'm going to skip all of these for a moment. I'm just going to say, here's the slide, here's the portion of the world and their degree of being malnourished. All those bright, bold greens, less than 5% of the population is malnourished. But all of the areas that will be impacted the most by climate change have these other colors where you have as much as 35% of the population malnourished. And that will only be worse if there's big changes in rainfall or big changes in the price of food. But, and I know Bristol is global, and we think that this is not a problem in the UK, but 1 million people used food banks last year. 20,000 families used food banks in Bristol last year. And most likely, poor nutrition, poor food deprivation is much worse than those numbers suggest. Because when food prices go up, people tend not to starve in the UK, they just eat poorer quality, lower nutrition food. They switch from having fresh food to canned food. Because if you're poor, you can't afford for your food to rot. So you get canned food because then you know at least you'll be able to use it. There's all sorts of nasty, nasty consequences that don't show up necessarily even in the food banks, but people eating less and less nutritious food when the price goes up. What was the number? The average, a single mother and her child in this country, I have to check with my colleague over in social sciences, Patricia Lucas, but the number is something like the two of them spend 18 pounds per week. No, it's per person, 18 pounds per person per week for a single mother. That's less than 1 pound per meal, assuming 3 meals a day. That is shocking, right? And then you get me coming in and say climate change because I don't know what's going to happen with rainfall and hotter temperatures and all sorts of weird infectious diseases and all sorts of things. I don't know what's going to happen to the price of that food that she's trying to buy for that 18 pounds per week. So all sorts of issues. If I were to summarize the specific, I've talked rather around generalities rather than specific consequences. This was something that emerged during a consultation. Some of it was with experts, some was with the public, in terms of what we thought Bristolians would be affected by most of climate change. The usual suspects came up: flooding, initially not warming, but then when people thought about heat waves, absolutely. The occasional cold shock, because you'll still have those if you have more extreme weather. But then people began to recognize that we do live in this interconnected world, and we will have impacts on food prices. We're seeing now impacts on migration, refugee crises, all happening because of the fact that we can't disconnect ourselves from the rest of the world. But ultimately, what most people were concerned about was not those, but the knock-on effects. The impacts on jobs and the economy, our security, our health, because that's what people really grapple with on a day-to-day basis. And those effects are really quite pernicious. And again, they won't be equal. So clearly, we have to do something about this. And it is not, I mean, I was saying to the guys right at the beginning, I said, because scientists are meant to be emotionally detached, when you're too emotionally engaged with the conversation, then people who sit on the fence, they will look at us and say, I don't trust your science because you're emotionally invested. So we talk about this as a term of ethics. These are ethical issues. But because we're talking about it, screw that. This should get you pissed off. Now, you're all young, so you're not, I'm sorry, you're not allowed to be depressed. I don't want to tell you what emotions you're allowed, but you can't be depressed. You have to have some ray of motivation. And the fact of the matter is if you're really depressed and thought there's nothing we can do about this, it's a terrible problem, all you've confirmed is that this is a terrible, stupid problem, you wouldn't be here in this room. The mere fact that you're in this room trying to think about and take, or maybe you're only in it for the 500 quid. But aside from that, you're here because you think, I can make a tiny little bit of a difference. And that is probably the emotion I would want to leave you with at the end, is to actually be inspired by this challenge. Because it is bad and should motivate us. And you can start with anger, but I'd say that's not going to solve the world's problems. Depression sure as hell is not going to solve it. Anger might keep you going through the rough patches, but it's also not going to solve the problems. Ultimately, we're going to have to find some degree of hope and inspiration. And we shouldn't be looking at this as, oh my God, if we don't do this, we're all going to die. We should be looking at this as something like, this is something to bring out the best in humanity. We can change our behavior. We can change who we are. So many of the behaviors that we think are absolutely intractable, that you could never change, have only existed in human society for 100 years. Some of them only for 50 years. Realize 150 years, we basically never used sugar. The world changes, our behavior changes. So before I get to specific ones around what we will do, and basically there's two types of challenges that we have. Stop polluting the planet, but recognize that some some pollution will happen, and we must help people adapt to that in an equitable way. I think it's useful to just actually look back and think, what are we capable of? You know, only a little bit over a century ago, we couldn't fly, right? We couldn't fly in 1905. This is what human ingenuity can do. Computers, right? There's all sorts of examples. The one on the left, that's sort of the first computer up in Manchester. That's huge. I think that thing could, that huge computer, I think what it was capable, I think it could add. That's what it could do. Now, these days, you have more computational power, by far, and more access to knowledge, by far, than the President of the United States had in the entirety of his government resources in the 1960s. This is a fundamental change in our ability to communicate, to learn, to understand our world, but also to perhaps tackle problems. But I put this up here to just show you how much the world can change. And you can be part of that. Another one, this is a little bit more biological. I do a little bit of research that touches on things like genomics issues, but we took 10 years to sequence the first human genome. We can now do most of you in this room in a month. We have had exponential change in our society. So just as we've had exponential change in our consumption and our degradation of the planet, we have also had exponential change in our knowledge and our technology. And so we can beat ourselves up on one hand and learn the lessons of that, but then we can think, but also although we can be a little irritated at ourselves for not taking action on this, we can actually look at ourselves and say, we are a fairly amazing species. And if we do embrace the challenge, we're capable of doing all sorts of things. So I just thought I'd throw up a few provocations for you all in terms of where we need to go. These are sort of big problems. And they're meant to excite you about your careers and where you could go and some of the big inspiring challenges that we have. They're not what you're going to talk about afterwards, but some of the things you talk about afterwards might be the first small steps on that journey. So how do we mitigate, let's just say, climate change? Well, we have to stop burning fossil fuels. That's fairly simple. I always say, as a geologist, I know quite fundamentally, it doesn't mean decreasing emissions. Decreasing emissions slows climate change. To stop climate change and to keep warming below about 5.5, 6 degrees, we have to stop burning fossil fuels. So we're going to have to change where we get our electricity from. That may appear trivial, but it's going to be hard. We may gripe and moan about fracking all the time and how we should be fracking and how we need to wean ourselves off gas. How many of you have gas central heating and a gas hob? Right? Now, 80% of our population has gas central heating. So we should be thinking not just about how we're going to change our electricity, but we're going to have to change our homes. Now we can either think, well, we can all do that really, really fast when we run out of gas, or maybe we can start on that today with a slow, gradual, fantastic, positive transformation of our economy. We're going to have to change transport, and we kind of sort of look at cars and think, yeah, but that's okay, we'll have an electrical grid in 50 years and we'll all drive electric cars. Or maybe we should be using more public transport, and maybe we can get creative in the public transport. You guys know what bus that is? Yeah, what's it called? Biobus, and then what's this other name?
Crew bus.
Crew bus? It is the crew bus. It's the number 2 line as well. I have to say, the whole issue, it's a world of ironies and contradictions. Basically, the number 2 line takes you from Bath to Bristol City Airport. So there is that. But as something that's ingenuity is that not only is it public transport, but it's public transport that is powered by biofuel, but also think about the cultural aspect of it. That they're clever enough to actually say something that actually maybe 10 years ago we all said was disgusting and would alienate people and discourage people. Actually, they'll say, you know what? I am happy with my own excrement being recycled to power this bus. I mean, that's actually a huge change up here. We need to fly differently. I know we have solar planes. Those solar planes are pretty cool. They can sort of, they just completed the first, round the world or transatlantic flight, I forget. I think there were 2 people in that plane. That's not really the solution. We might have solar planes. We might have planes powered by small modular nuclear reactors. I don't know, but all I know is that you're going to have to move 300, 400 people around in a plane. We fly less, but we're not going to stop flying. We can recycle and upcycle more of our supplies locally, but we will need a global supply chain. We can't be isolated from the rest of the planet. That means we need to move things around without these, or we need these shipping vessels powered by something other than petrol. We don't know how to make steel without burning coal. So we're going to have to come up with new solutions. Maybe we use less steel. Maybe we just stop using steel entirely and we go all to alternative things. Maybe we make more polymer-based. Maybe we make all sorts of alternative-based materials. Or maybe we make steel, but we make it with geothermal power. But at some point, this is a challenge we're going to have to think about. And ultimately, we are going to have to suck some of this carbon dioxide out of the atmosphere and find some way to do it. It's not going to be all of our problems, but it's solve all of our problems, but we're going to have to do some tiny part of it. Now that's, because I knew I was talking mostly to engineers and scientists, I've emphasized the technological solutions, and I've tried to emphasize that in a way that makes you think about some of the real fantastic challenges that will create, but it is not all technology. We will have to change the way we live, and by that I mean in more fundamental ways than being willing to ride on a bus that's powered by poo. We'll have to do more than that, and we're going to need to come up with new fundamental behavioral solutions. The other thing is, I do think, because there is such an ethical dimension to this, that people will suffer differently, we can no longer have the argument, all I'm going to think about is solving the climate change problem. I don't want to talk about adaptation or resilience to climate change, because if I talk about that, then people won't do this. It's too late for that. We need to talk about both. We need to talk about minimizing climate change or environmental pollution or biodiversity loss. And we need to think about the consequences of what will happen. We're already 1 degree in the pipeline. And no matter what happens, we will warm the planet by one of those numbers. 2 degrees, that's what the Paris Agreement said. We will limit warming to 2 degrees. 1.5 degrees is the aspiration, and that aspiration was led by small island states, particularly the Marshall Islands, because 2 degrees means that a large number of relatively small nations will cease to exist probably by the end of the century. So 2 degrees was unacceptable to them, so we have this aspiration for 1.5 degrees. The commitments that all the nations made in advance of it are 3 degrees. Most campaigners argue that national policies are not at all in line of even their commitment to limit warming to 3 degrees. By and large, we're still relatively on the business as usual approach. We've just pushed it a little bit further down the road. We have slowed it, we have not stopped it. How much warming we'll eventually have to grapple with and on what time frame remains a big question. I'm certain that we will avoid the worst of those. There's been too many positive developments, there's too much technology in the pipeline, the economy will eventually shift away from fossil fuels. There's just too many exciting things happening. Right now, these days, I'm actually more worried about the UK being left behind by this new intellectual and technological revolution. But nonetheless, this is all in the pipeline. But we very well might be dealing with 3 degrees of warming. As I said, it's very hard for me to tell you what 3 degrees of warming might mean in terms of food prices, flooding, these types of issues that actually matter in most populations. We even talked about ocean acidification, which could affect our coral reefs, on which our global fish supplies depend. So there's all sorts of issues, and we're going to go into a world that's going to be much, much more uncertain. And we're no longer going to be able to think about controlling our planet and preventing disasters. This is another deep psychological change that is going to happen. You hear it after every natural disaster. We heard it after the Somerset floods, we heard it after the Cumbrian floods. What money should have been spent to prevent this from happening? How do we control it? Ultimately, we're going to have to shift into a mode of not just controlling it with walls or even high-tech, fancy things like the Thames Barrier, although the Thames Barrier is really cool and is fantastic in a lot of ways, we're just going to have to acknowledge sometimes these things will happen, and when they happen, they have to have far, far, far less of an impact than they currently do. We can't have Hurricane Katrina. That doesn't mean that that we will prevent this by preventing the flooding. What we need to do is say that when it does flood, we bounce back faster, it is not unfair in its impacts, and the impacts are relatively small. And this gets a lot of people, again, thinking about issues like social cohesion, resilience contracts, sharing resources. What is our responsibility to the rest of the planet as a nation when the Marshall Islands disappear beneath the sea? I think we should talk about that now rather than in the future. I think our engineers should be thinking more creatively about how communities build their own flood defenses, how they become more adroit. We talk a lot about social cohesion. During a typical flood event in the UK, 98% of the people are evacuated by their neighbors, themselves, or local authorities. It is not the National Guard coming in. It is not the government. It is not helicopters, if that's what in the news. It's people, communities, working together. Social cohesion will be key. We'll have to rethink our engineering. I have no idea if this is feasible, but I love throwing up here to just annoy my engineering friends. All my engineers always say, whenever you're building something that says bridge, a road, a rail line, we have to get it right because we'll be stuck with this for the next 150 years. Why? I don't know what the world's going to be like in 150 years. Why are we committing ourselves to 150 years? That's what the Victorians and the Georgians did. And right now we have a city, Bristol, that is not at all fit for purpose. Thank you, Victorians and Georgians, for designing a bowl of spaghetti type of road system. Why? We need to start maybe thinking about building things more as a Lego world, where the materials are precious. We are upcycling and recycling. We're not throwing things away. We're not putting in landfills. But the buildings and the infrastructure themselves can be remobilized, transformed, that they can be adroit and as flexible as you guys need to be. And I also think there's a prominent role for smart cities. And again, it's how people use the smart cities as well as the technology. Ways to build resilience and adaptability in the system, or maybe even to become more sustainable. All sorts of interesting things. And I know that they're going to be a little bit, bigger picture than what I think you guys want to go away and tackle. But it's useful to sort of do a bit of horizon scanning to think about what you might do and how it might be part of an ongoing thing. Smart cities is a great example. Everybody loves smart cities. And no one actually knows what the hell smart cities are going to do. Which is why the main thing that's happening in smart city space is hackathons and things like that, where people come up with a creative app that lets people interact with the smart city and come up with their own solution. One of the most successful things this year is someone came up with a thing called a crocodile app. Some of our people, I think in psychology, no, computer science? Okay, they're working with the company that developed this crocodile app. What it is it helps groups of parents get together, use the crocodile app, walk their kids to school. So the app, using the smart city technology and using this, means that they have healthier behavior, less congestion, less air pollution, less carbon emissions, and it's something just as simple as changing the school run. 50 years ago, you would have just sent the kids off to school, walk one by one. Right now, parents all seem to drive their SUVs to drop the kids off to school one at a time. Maybe we're not going to go back to what it was 50 years ago, but maybe we find a compromise where groups of parents using different apps and building sort of virtual communities are able to walk groups of kids. So it doesn't need to be Bristol is open, big transformative city. It could be small interventions that help us 10 years from now really make the most of this. So when I lecture my chemistry students, I talk about this. What I often say is, you guys have this big challenge put in front of you. I'm still young enough that I also have a big challenge put in front of me. If there's any silver lining to it, is that these challenges can be inspiring and they can be motivating. A lot of people in my generation, if you come up with a really inspired, interesting idea, people will say, yeah, but I kind of like things the way they are, I don't need to do anything. This change, this uncertainty will be uncomfortable, but it will also be provocative. So, although it will be challenging, I think you are going to live in a far more interesting and stimulating, more creative world. than the one we have today. And that doesn't really matter if you're poor and a refugee in Africa, but if we could begin to square the circle between our ethical obligations and the creativity the solutions will inspire, then I think that's a real positive, emotional approach to take to it. I try to use the anger to get me out of bed, and I try to use the optimism to get me through the day. And that's the last I'll leave you with, and I guess we have a few moments that I can answer any questions, or you can just discuss this amongst yourselves. Right. But thank you very much, and thanks again, guys, for working.